Chapter 11 Network Address Translation for IPv4. There are not enough public IPv4 addresses to assign a unique address to each device connected to the Internet. Networks are commonly implemented using private IPv4 addresses as defined in RFC 1918. NAT provides the translation of private addresses to public addresses. This allows a device with a private IPv4 address to access resources outside their private network, such as those found on the Internet. Without NAT, the exhaustion of the IPv4 address space would have occurred well before the year 2000. However, NAT has certain limitations. The solution of the exhaustion of IPv4 address space and the limitations of NAT is eventual transition of IPv6. What is NAT? Its primary use is to conserve public IPv4 addresses. It does this by allowing networks to use private IPv4 addresses internally and providing translation to a public address only when needed. NAT-enabled routers can be configured with one or more valid public IPv4 addresses. These public addresses are known as the NAT pool. When an internal device sends traffic out of the network, the NAT-enabled router translates the internal IPv4 address of the device to a public address from the NAT pool. A NAT router typically operates at the border of a stub network. A stub network is a network that has a single connection to its neighboring network, one way in and one way out of the network. In the example in the figure, router 2 is a border router. As seen from the ISP, router 2 forms a stub network. When a device inside the stub network wants to communicate with a device outside of its network, the packet is forwarded to the border router. The border router performs the NAT process, translating the internal private address of the device to a public outside routable address. NAT terminology. In NAT terminology, the inside network is the set of networks that is subject to translation. The outside network refers to all other networks. NAT includes 4 types of addresses: inside local address, inside global address, outside local address, and outside global address. When determining which type of address is used, it is important to remember that NAT terminology is always applied from the perspective of the device with the translated address. Inside address is the address of the device which is being translated by NAT. Outside address is the address of the destination device. NAT also includes the concept of local or global with respect to addresses. Local address. A local address is any address that appears on the inside portion of the network. Global address. A global address is any address that appears on the outside portion of the network. The terms inside and outside are combined with the terms local and global to refer to specific addresses. In the figure, router R2 has been configured to provide NAT. It has a pool of public addresses to assign to inside hosts. Inside local address is the address of the source as seen from the inside network. In the figure, the IPv4 address 192.168.10.10 is assigned to PC1. This is the inside local address of PC1. Inside global address is the address of the source as seen from the outside network. In the figure, when traffic from PC1 is sent to the web server at 209.165.201.1, R2 translates the inside local address to an inside global address. In this case, router 2 changes the IPv4 source address from 192.168.10.10 to 209.165.200.226. In NAT terminology, the inside local address of 192.168.10.10 is translated to the inside global address of 209.165.200.226. Outside global address is the address of the destination as seen from the outside network. It is globally routable IPv4 address assigned to a host on the Internet. For example, the web server is reachable at IPv4 address 209.165.201.1. Most often, the outside local and outside global addresses are the same. The outside local address is the address of the destination as seen from the inside network. In this example, PC1 sends traffic to the web server at the IPv4 address 209.165.201.1. While uncommon, this address could be different than the globally routable address of the destination. Types of NAT. Static NAT uses one-to-one address mapping between local and global addresses. It is particularly useful for web servers or devices that must have a consistent address that is accessible from the Internet, such as a company web server. It is also useful for devices that must be accessible by authorized personnel when off-site, but not by the general public on the Internet. Static NAT requires that enough public addresses are available to satisfy the total number of simultaneous user sessions. Dynamic NAT uses many-to-many address mapping between local and global addresses. In other words, it uses a pool of public addresses and assigns them on a first-come, first-served basis. When an inside device requests access to an outside network, Dynamic NAT assigns an available public IPv4 address from the pool. PAT uses many-to-one address mapping between local and global addresses. This method is also known as overloading. In other words, it maps multiple private IPv4 addresses to a single public IPv4 address or a few addresses. This is what most home routers do. The ISP assigns one address to the router, yet several members of the household can simultaneously access the Internet. This is the most common form of NAT. PAT ensures that devices use a different TCP port number for each session with a server on the Internet. When a response comes back from the server, the source port number, which becomes the destination port number on the return trip, determines to which device the router forwards the packets. Advantages and disadvantages of NAT. Advantages. NAT conserves the legally registered addressing scheme by allowing the privatization of intranets. NAT also conserves addresses through application port-level multiplexing. NAT increases the flexibility of connections to the public network. Multiply pools, backup pools, and load balancing pools can be implemented to ensure reliable public network connections. NAT provides consistency for internal network addressing schemes. On the network not using private IPv4 addresses and NAT, changing the public IPv4 address scheme requires the addressing of all hosts on the existing network. The cost of redressing hosts can be significant. NAT provides network security. Because private networks do not advertise their addressers of internal topology, they remain reasonably secure when used in conjunction with NAT to gain control external access. However, NAT does not replace firewalls. Disadvantages. NAT does have some drawbacks. The fact that host on the Internet appears to communicate directly with the NAT-enabled device rather than with the actual host inside the private network creates a number of issues. End-to-end addressing is lost. Many Internet protocols and applications depend on end-to-end addressing from the source to the destination. Some applications do not work with NAT. Using NAT also complicates tunneling protocols, such as IPsec, because NAT modifies values in the headers that interfere with the integrity checks done by IPsec and other tunneling protocols. Services that require the initiation of TCP connections from the outside network or stateless protocols such as those using UDP can be disrupted. Configuring static NAT. Static NAT is one-to-one mapping between an inside address and an outside address. Static NAT allows external devices to initiate connections to internal devices using the statically assigned public address. For instance, an internal web server may be mapped to a specific inside global address so that it is accessible from outside networks. Usually, static translations are used when clients on the outside network need to reach servers on the inside network. Steps to configure static NAT are shown on the right side. Verifying static NAT. A useful command to verify NAT operation is the show IP NAT translations command. This command shows active NAT translations. Static translations, unlike dynamic translations, are always in the NAT table. Another useful command is the show IP NAT statistics command. It displays information about the total number for active translations. NAT configuration parameters, the number of addresses in the pool, and the number of addresses that have been allocated. To verify that the NAT translation is working, it is best to clear statistics from any past translations using the clear IP NAT statistics command before testing. Prior to any communications with the web server, the show IP NAT statistics command shows no current hits. After the client establishes a session with the web server, the show IP NAT statistics command has been incremented to 5 hits. This verifies that the static NAT translation is taking place on router 2. Dynamic NAT operation. Dynamic NAT allows the automatic mapping of inside local addresses to inside global addresses. Dynamic NAT uses a group or pool of public IPv4 addresses for translation. Dynamic NAT, like static NAT, requires the configuration of the inside and outside interfaces participating in NAT. Where static NAT creates a permanent mapping to a single address, Dynamic NAT uses a pool of addresses. In this slide, we can see the steps to configure Dynamic NAT. Verifying Dynamic NAT. The output of the show IP translations command shown displays the details of the 2 previous NAT assignments. The command displays all static translations that have been configured and any dynamic translations that have been created by traffic. Adding the verbose keyword displays additional information about each translation, including how long ago the entry was created and used. To clear dynamic entries before the timeout has expired, use the clear IP NAT translation privilege exec mode command. Specific entries can be cleared to avoid disrupting active sessions. Use the clear IP NAT translation asterisk privilege exec mode command to clear all translations from the table. Show IP NAT statistics command displays information about the total number of active translations, NAT configuration parameters, the number of addresses in the pool, and how many of the addresses have been allocated.
So now we'll check out how to configure port address translation, also called PAT. PAT, also called NAT overload, conserves the addresses in the inside global address pool by allowing the router to use one inside global address for many inside local addresses. Now, an important thing to note here is that the number of internal addresses that can be translated to one external address could theoretically be as high as 65,536 per IP address. However, the number of internal addresses that can be assigned a single IP address is around 4,000. Now, there are 2 ways to configure PAT, depending on how the ISP allocates public IPv4 addresses. In the first instance, the one we're going to see next, the ISP allocates more than one IPv4 address to the organization, and in the other, it allocates a single public IPv4 address that is required for the organization to connect to the ISP. Now we'll see how to configure PAT for a pool of public IP addresses, the first one. So, configuring PAT for address pool. If a site has been issued more than one public IPv4 address, these addresses can be part of a pool that is used by PAT. Now, this is similar to dynamic NAT, except that there are not enough public addresses for a one-to-one mapping of inside to outside addresses. The small pool of addresses is shared among a larger number of devices. Now, here in Figure 1, we can see the steps to configure PAT to use a pool of addresses. Now, it's important to note that the primary difference between this configuration and the configuration for dynamic one-to-one NAT is that the overload keyword is used. It actually enables PAT. So here we can see step 1, define a pool of global addresses to be used for overload translation. There's a command. Next step is to define a standard access list permitting the addresses that should be translated. Step 3 is to establish overload translation, specifying the access list and pool defined in prior steps. Now we can see the use of the word overload. And in step 4 is to identify the inside interface, and step 5 is to identify the outside interface. So now we'll see how to configure PAT for a single address. Now, I mean, here we can also see figure 1, which defines the steps to follow. So the first step is to define a standard access list permitting the addresses that should be translated. Step 2 is to establish dynamic source translation, specifying the ACL, exit interface, and overload options. Now we can also see here the overload keyword. Step 3 is to identify the inside interface, and step 4 is to identify the outside interface. It's somewhat similar to what we saw in the previous slide. Now, if only a single public IPv4 address is available, the overload configuration typically assigns the public address to the outside interface that connects to the ISP. This means that all inside addresses are translated to the single IPv4 address when leaving the outside interface. Now we'll move on to analyzing paths. Now there are two ways to analyze paths. I mean, you can go from PC to server or from server to PC. Now, in here we can see the analysis from PCs to servers. Now, this figure shows both PC1 and PC2 sending packets to SVR1 and SVR2 respectively. But PC1 has the source IPv4 address 192.168.10.10, seen right here, and it is coincidentally assigned to the same source port of 1444. Now, the packet from PC1 reaches R2 first, using PAT. R2 modifies the source IPv4 address to the 209.165.200.225, which is the inside global address. Now, there are no other devices in the NAT table using port 1444, so PAT maintains the same port number. The packet is then forwarded towards SVR. Next, the packet from PC2 arrives at R2. PAT is configured to use a single inside global IPv4 address for all translations, which is 209.165.200.225. Similar to the translation process for PC1, PAT changes PC2 source IPv4 address to the inside global address 209.165.200.225. However, PC2 has the same source port number as the current PAT, and the translation for PC1. PAT increments the source port number until it is a unique value in its table. In this instance, the source port entry in the NAT table and the packet for PC2 receives 1445. Now, although PC1 and PC2 are using the same translated address, the inside global address of 209.165.200.225 and the same source port number of 1444, the modified port number for PC2, 1445, makes each entry in the NAT table unique. Now, this will become evident with the packets sent from the servers back to the clients. So now we'll see the second way to analyze paths, which is from servers to PCs. Now, as shown in this figure, in a typical client-server exchange, SVR1 and SVR2 respond to the requests received from PC1 and PC2 respectively. The servers use the source port from the received packet as a destination port, and the source address as a destination address for the return traffic. The servers seem as if they are communicating with the same host, however, this is not the case. Now, as the packets arrive, R2 locates the unique entry in its NAT table using the destination address and the destination port for each packet. In the case of the packet from SVR1, the destination IPv4 address of 209.165.200.225 has multiple entries, but only one with the destination port 1444. Now, using the entry in its table, R2 changes the destination IPv4 address of the packet to 199.168.10.10 with no change required for the destination port whatsoever. The packet is then forwarded towards PC1. Now, lastly, when the packet from SVR2 arrives, R2 performs a similar translation. The destination IPv4 address of 209.165.200.225 is located, again with the multiple entries. However, using the destination port of 1445, R2 is able to uniquely identify the translation entry. The destination IPv4 address is changed to 192.168.10.11, and in this case, the destination port must also be modified back to its original value of 1444, which is stored in the NAT table. The packet is then forwarded toward PC2. So now we've seen how to analyze paths and how to configure it using both ways. So now we'll move on to checking out how to verify paths. The important thing is that the same commands used to verify static and dynamic paths are used to verify paths. So, I mean, here we can see that the show IP NAT translations command displays the translations from two different hosts to different web servers. Notice that the two different inside hosts are allocated the same IPv4 address of 209.165.200.226, which is the inside global address, and the source port numbers in the NAT table differentiate the two transactions. Now, as shown in this figure, the show IP NAT statistics command, right here, verifies that NAT pool 2 has allocated a single address for both, for both translations. Included in the output is information about the number and type of active translations, and NAT configuration parameters, the number of addresses in the pool, and how many have been allocated. So now we'll learn about port forwarding. Port forwarding, sometimes referred to as tunneling, is the act of forwarding a network ports from one network node to another. This technique allows an external user to reach a port on a private IPv4 address inside a LAN from the outside through a NAT-enabled router. Now, it is also typically peer-to-peer file sharing programs and operations such as web serving and outgoing FTP require that router ports be forwarded or opened to allow these applications to work, as shown in another figure, which is not here, but anyway. Because NAT hides internal addresses, peer-to-peer only works from the inside out, where NAT can map outgoing requests against the incoming replies. The problem is that NAT does not allow requests initiated from the outside. This situation can be resolved with manual intervention. So port forwarding can be configured to identify specific ports that can be forwarded to inside hosts. Now here in this figure, right here, this figure shows a small business owner using a point of sale, POS, server to track sales and inventories at the store. The server can be accessed within the store, but because it has a private IPv4 address, it is not publicly accessible from the internet. Enabling the local router for port forwarding allows the owner to access the point of sale server from anywhere on the internet. Now, port forwarding on the router is configured using the destination port number and the private IPv4 address of the point of sale server. To access the server, the client software would use the public IPv4 address of the router and the destination port of the server. So now we'll see how to configure port forwarding using iOS. Now in this figure, we can see how the static NAT command used to configure port forwarding using iOS is done. For example, here we have a list of parameters and its descriptions. For example, TCP indicates if this, or UDP indicates if this is a TCP or UDP port number, and well, you should pause the video and take a minute to check out the different types of parameters and its descriptions, and their descriptions. So now we'll check out an example. Right here, okay. Now, this figure shows an example of configuring port forwarding using iOS commands on router R2. Now, 192.168.10.254 is the inside local IPv4 address of the web server listening on port 80, as it's shown in the figure. Users will access this internal web server using the global IP address 209.165.200.225, a globally unique public IPv4 address. In this case, it is the address of the serial 0/1/0 interface of R2. The global port is configured as 8080, and this will be the destination port used along with the global IPv4 address to access the internal web server. Notice within the NAT configuration, the following command parameters: local IP, which is 192.168.10.224, the local port, which is 80, the global IP, which is 209.165.200.225, and the global port, which is 8080. Sorry, the local port is this one. Now, when a well-known port number is not being used, the client must specify the port number in the application. And like the other types of NAT, port forwarding requires the configuration of both the inside and outside NAT interfaces. Now we'll see how to configure NAT and IPv6, which is somewhat strange because, well, as we know, because IPv6 has 128-bit addresses, it provides sorry, here I'm missing an S. It provides 340 undecillion addresses, which is a really big number, and this means that the address space is not an issue. It was developed with the intention of making NAT for IPv4 with its translation between public and private addresses unnecessary. However, IPv6 does implement a form of NAT, which includes both its own private address space and NAT, which are implemented differently than for IPv4. So it is important to take note and see which are these differences. Now, there's the unique local addresses. IPv6 unique local addresses are similar to RFC 1918 private addresses in IPv4, but there are significant differences as well. For example, the intent of ULA is to provide IPv6 address space for communications within a local site, while it is not meant to provide additional IPv6 address space, nor is it meant to provide a level of security. Now, as shown in this figure, ULA have the prefix FC00:7, which results in the first hex that range from FC00 to FDFF. Now, the next 1 bit is set to 1 if the prefix is locally assigned. Set to 0 may be defined in the future. The next 40 bits is a global ID followed by a 16-bit subnet ID. These first 64 bits combine to make the ULA prefix. This leaves the remaining 64 bits for the interface ID, or in IPv4 terms, the host portion of the address. This figure clearly shows the prefix, the global ID, the subnet ID, and the interface ID, and the other bit, which may be set to 1 or 0 in the future. Now, as for NAT for IPv6, it is used in a much different context than NAT for IPv4. The varieties of NAT for IPv6 are used to transparently provide access between IPv6 only and IPv4 only networks. It is not used as a form of private IPv6 to global IPv6 translation, as it would be for IPv4. Now, ideally, IPv6 should be run natively wherever possible, which means that the IPv6 devices communicating with each other over IPv6 networks. It means that IPv6 devices communicating with each other will communicate with each other over IPv6 networks. However, to aid in the move from IPv4 to IPv6, the IETF has developed several transition techniques to accommodate a variety of IPv4 to IPv6 scenarios, including dual stack tunneling and translation. Dual stack is when the devices are running protocols associated with both IPv4 and 6. Tunneling for IPv6 is a process of encapsulating the IPv6 packet in an IPv4 packet, which allows the IPv6 packet to be transmitted over an IPv4 only network. Now, NAT for IPv6 should not be used as a long-term strategy, but as a temporary mechanism to assist in the migration from IPv4 to IPv6, which we know is an undergoing process and will take some more time, which is why it's important to learn about this. Now we'll take a look at troubleshooting for NAT. This figure shows R2 enabled for paths using the range of addresses 209.165.200.226 to 209.165.200.240, which is here, the NAT pool. So when there are IPv4 connectivity problems in a NAT environment, it is often difficult to determine the cause of a problem. The first step in solving the problem is to rule out NAT as a cause. Now, we should follow these steps to verify that NAT is operating as expected. Step 1 is, based on the configuration, clearly define what NAT is supposed to achieve. This may reveal a problem with the configuration. Step 2 is to verify that correct translations exist in the translation table using the show IP NAT translations command. Step 3 is to use the clear and debug commands, which are really useful, especially the debug one, to verify that NAT is operating as expected. And check to see if dynamic entries are recreated after they are cleared. Step 4 is to review in detail what is happening to the packet and verify the routers have the correct routing information to move the packet. Now, this figure shows the output of the show IP NAT statistics command and here. And show IP NAT translations commands. Now, prior to using the show commands, the NAT statistics and clear entries in the NAT table are cleared. So after the host at 192.168.10.10 telnets to the server at 209.165.201.1, the NAT statistics and NAT tables are displayed to verify NAT is working as expected. It's really important to clear the IP NAT statistics and translation before, because if not, it can yield devious results. Now we'll take a look at the debug command. The important debug commands are debug IP NAT, debug IP detailed, and debug IP NAT detailed. This figure shows the debug IP NAT command and its output. The output shows that the inside host initiated traffic to the outside host. This is the inside host and this is the outside host. And the source address was translated to address 209.165.200.226. Sorry, this is the outside host. Now here we can see a lot of weird notation. For example, this asterisk. The asterisk next to a NAT indicates that the translation is occurring in the fast switched path. The first packet in a conversation is always process switched, which is slower, and the remaining packets go through fast switch path if a cache entry exists. Now, this S equals means that this symbol refers to the source of IPv address. And this part, which is the address followed by a right arrow to another address, indicates that the source address, the source address is translated to this address over here. And this should be all. Okay. So, as a quick summary, sorry, this should be chapter. As a quick summary, this chapter discussed NAT for IPv4, including its characteristics, general operations, and terminology, the different types of NAT, static, dynamic, and PAT, the benefits and disadvantages of NAT, the configuration, verification, and analysis of all types of NAT, how port forwarding can be used to access an internal device from the internet, and troubleshooting NAT using the show and debug commands.